since only one electron has a valence electron, it has a capacity to lose that electron, hence their oxidation state will be +1. Deuterium will be mainly used in the form of deuterium oxide, which is also known as heavy water. We can easily prepare the hydrogen gas by using barium hydroxide and also by using nickel as a electrode by electrolysis process. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with the new unit called hydrogen. So before going to discuss with this new unit, let's see the weightage of this unit. So from this unit, we can expect one 3-mark question. Remember, the question number from the part C, that is 24, will come from this unit and the total weightage will be 3. So it is very simple. So we can expect one 3-mark question. Remember again, sometime they will ask the 3-mark question directly and sometime it will be split into 2 plus 1. Okay. Let's see what we are going to discuss in this session. So in this session, we are going to understand the position of hydrogen in the periodic table and we are going to understand resemblance of the hydrogen with alkali metals and we are going to understand resemblance of the hydrogen with halogen family. How does the hydrogen is related to or resembles to the alkali metal and how does the hydrogen which is also resembles to the halogen we are going to understand and the occurrence in their nature and their preparation of dihydrogen we are going to understand. So let's see the position of hydrogen in the periodic table. We all know that in our periodic table, there are 118 elements will be there. The first and foremost element is the hydrogen. Is it right? And we all know that hydrogen is the first element and it is one of the lighter element when it is compared with the other group of element. Is it right? Yes. It is the lightest element known with having an atomic number of 1. Is it right? So we always write hydrogen atomic number as 1 and their electronic configuration will be 1s1. Is it right? So it is a first element in our periodic table which is having the only 1 atomic number. And it is also expressed in the form of dihydrogen. So we always write it in the H2 form. Okay. So it resembles both alkali metals and halogen, therefore the position is anomalous. So when we look at the hydrogen, it also resembles the alkali metal but also it resembles to the halogen. Okay. So that is why the position in the periodic table for the hydrogen is anomalous. Okay. And in the modern periodic table, it has been located separately. So already we have discussed about the classifications of the elements and periodicity in property. By learning the Mendeleev periodic law, we have understood that the position of the hydrogen in the periodic table is not so clear because it resembles both alkali metal as well as with the hydrogen. Later, Henry Moseley, he has kept the hydrogen separately in the periodic table. Why it is like that? Because the hydrogen atom being a lighter having only 1 atomic number and its property will be entirely different from the other rest of the element. That is why in the modern periodic table we have kept the hydrogen separately because of its anomalous behavior. Let's see how does the hydrogen which also resembles to the alkali metals. Okay. It has 1 electron in its valence shell. We know that in a group 1 element, that is alkali element, The first element is hydrogen, lithium, sodium, potassium, rubidium and cesium. Is it right? All this element, we all know that it consists of only one electron in its valence shell. So I can write the example of hydrogen as well as in the lithium. Okay. So this is a structure of hydrogen. In the K shell, there is only one electron will be there and the electronic configuration will be 1s1. Similarly, for the lithium, it is 1s2, 2s1. Is it right? So in the K shell, there are 2 electrons and followed by the L shell, which consists of only 1 electron. This shows that in group 1 elements which is having only 1 electron in its valence shell, whereas our hydrogen is also having only 1 electron. That is why the hydrogen, which also resembles to the alkali metal because of the presence of only 1 electron in its last shell, that is in the valence shell. Hence their valency is 1. It has tendency to lose electron and to form a H plus ion. Is it right? So it can loses this electron and become H plus ion. Similarly, the lithium can lose this electron and become what? Lithium plus. So it has a tendency to lose how many electrons? Only 1 electron because it present in the valence shell. Okay. And it has more affinity with the non-metals. So it has affinity towards the non-metal, hence it is behaving like a resembles to the alkali metals. And it has an oxidation state of +1. So already I have explained that both in alkali metal as well as in the hydrogen, it consists of only 1 electron in its outermost shell. Since it consists of only 1 electron as a valence electron, it has a capacity to lose that electron, hence their oxidation state will be +1. Okay. And many of the compounds with the water, generally hydrogen liberations will be occurs at cathode on electrolysis. If you do the electrolysis, generally the hydrogen gas will be liberated at cathode. And it acts as very good reducing agent for many of the reaction. It is very, very important. Already we know that why hydrogen will be act as a reducing agent. We also know that alkali metals, lithium, sodium, potassium, all this element which is also used as a very good reducing agent. And also our hydrogen, which also act like a very good reducing agent in many of the reaction. These are the important characteristics of the alkali metals and hydrogen and their resemblance. Now, let's see the differences between hydrogen with the alkali metals. Okay. The hydrogen is a non-metal, whereas the other metals of the group 1 are metals. So we know that hydrogen is a non-metal, but group 1 elements are nothing but a metal. That is the first differences. And second differences is hydrogen can form covalent and ionic bond, but we know that the group 1 elements which always forms what? Ionic compound. That is why the sodium which reacts with the halogen form sodium chloride. Similarly, the potassium react with the chlorine and form a potassium chloride. So, because the alkali metals, the group 1 elements, they forms what? Ionic compound. But hydrogen, it can form both ionic as well as with the covalent compounds. And hydrogen does not form H plus ion easily as alkali metal. Why it is? Because we know that alkali metal, it is having the atomic number in a 311 in that ratio. When it is having a only 1 electron in its outermost shell, it can easily donate it. But we know that the hydrogen atom, which is having only one electron. So, for the removal of this electron, we need a extra energy. It's not so easy to remove the one electron. But in other alkali metals, even though it is having the electron, but in the valence shell, it is having only one electron. So, it is very easy for them to lose one electron and to show their +1 oxidation state. Whereas for the hydrogen, it is not very easy as compared with the alkali metal because it consists of only one electron in its shell. Hence, it cannot easily form a H+ ion. The hydrogen is a gas at room temperature, but the alkali metals are usually solid. Okay, that is the fourth differences. Like sodium ion and potassium ion, the hydrogen ion does not exist freely in the aqueous solution. It always exists in hydronium ion. So, what does it indicate? We know that when we dissolve the sodium chloride in water, so it forms what? Sodium ion and chloride ion. Is it right? But when we talk about the hydrogen ion, that is H+ ion, it cannot present individually. It always present in hydronium ion formation, that is H3O+ ion. So, hope you all understood the differences between alkali metals with the hydrogen. We have understood that how hydrogen is resembles to the alkali metal, and also we have understood that how alkali metals is different from the hydrogen. Now let us see the resemblance of the hydrogen with halogens. Okay, it has one electron lesser than the next inner shell, example helium. So if you take the helium, there are 4 electrons will be there, that is atomic number will be 4 and electronic configuration will be 1s2, 2s2. We know that for a hydrogen there are 1 electron will be there and electronic configuration will be 1s1. If you write the atomic structure for the helium, in the K shell there are 2, next followed by a L shell, it consists of 2 electrons. You can see that in the hydrogen, this is a K shell which consists of only 1 electron, this is a valence shell. But for the helium, L shell is a valence shell which is having 1 extra electron. Is it right? It consists of only 1 valence electron. Here, the valency of the helium is 2. This indicates that it has 1 electron lesser than the inert gases. Okay. So, when you consider the helium as the best example for the noble gases which consists of 2 electrons in its valence shell, whereas our hydrogen which consists of only 1 electron in its valence shell, so which is lesser than the inert gas configuration. So, that is why I have put this point as a resemblance, and it has tendency to gain electron and to form a hydrate ion. So, this hydrogen atom easily it can accept 1 more electron to get a stable electronic configuration. Is it right? That is why this hydrogen can accept 1 more electron and become H- ion. So, this H can accept 1 electron and become what? H-. That is hydrate ion. It also forms a covalent compound. Both the inert gas, or you can say that halogen as well as our hydrogen can form what? Covalent compounds. In alkali and alkaline earth metal hydrate, it has oxidation state of -1. So, when we look at it, the alkali and alkaline earth metal, in alkali metal, they have +1 oxidation state. Whereas in alkaline earth metal, it has +2 oxidation state. Whereas our hydrogen, we know that it exhibits in +1 oxidation state. That is the second thing. and it always exhibit in diatomic molecule. Why? We know that the hydrogen will having only one electron. That is why it is not so stable. It always requires one more electron. That is why it exhibit in diatomic form. Okay, and its ionization energy is 13.6 electron volt, which is very much closer to the halogen ionization energy. So when we compare to their ionization energy also, it is almost very closer. This shows that our hydrogen can also resembles to the halogen, which is present in the group 17. Next we'll see with the differences between the hydrogen with the halogen. Okay. The hydrogen has one electron in its valence shell, whereas halogen, it has 7 electrons. So you can take example of chlorine, bromine, iodine, as well as with the chlorine you can take as a best example. We know that the chlorine, which consists of 17 electron, and if you write the shell for that, so this is a K shell, next is L shell, followed by so it is K, L, M. You can see that in the outermost shell, it consists of 7 electron, hence its valency will be 7. But whereas in the hydrogen, we know that it has only 1 electron in the K shell, hence the valency will be 1. And electronic configuration of hydrogen is 1s1, and the electronic configuration of halogen, it is ns1 and np5. Unlike the halogen ion, H- ions are also unstable in water and it can react quickly. So we know that halogen can accept the electron and get the negative charges. Even our hydrogen also, it can accept one more electron and become H- ion. Both will be unstable and it can easily react with water. The less tendency of a hydrate formation, that is, hydrogen has less tendency to take up the electron to form a hydrate ion as it is compared with the halogen, because the halogen can easily form a halide ion by accepting one electron. So this is another important thing that you must know, that halogen can easily accept the electron because of its valence shell. In order to get a stable electronic configuration, it can easily accept the electron as it is compared with the hydrogen. Absence of unshaped pair of electron and nature of oxides. The oxides of halogen are acidic in nature, whereas the oxides of hydrogen, they are neutral in nature. So these are the resemblance as well as the differences between hydrogen with the halogen. Next, we'll see with the occurrence of the hydrogen in the nature. Already I have told that the hydrogen will not present in a single form. It always present in a diatomic form. Is it right? So let's see how does it occurs in the nature in the form of dihydrogen. Hydrogen occurs throughout the universe. Mainly it occurs in the stars and in empty spaces. Between the stars, the hydrogen is the most abundant element which is found in the universe. Nearly 70% of total mass of the universe, it is made up of what? Hydrogen. And it is also occurs in the plants and animal tissues and carbohydrate, protein and hydrates, including the hydrocarbons. Many of these compounds are made up of hydrogen. The best example I can give you is in the hydrocarbon, we know that the carbon form a bond with the hydrogen by forming methane. So this is how we can say that the 70% of the universe is made up of what? Hydrogen only, which is exhibited in dihydrogen form. Let's see with the isotopes of the hydrogen. So there are three isotopes will be there for the hydrogen. They are protium, deuterium and tritium. So we'll see with what is protium, deuterium and tritium one by one. So I'll go with the protium now. Hydrogen 1, it is called as protium and it is the simplest and most common form of hydrogen, and ordinary hydrogen, which is also known as protium, it has one electron, one proton but no neutron. So it consists of how many electrons? One proton and one electron and no neutron. Hence it is known as hydrogen 1 or protium, and it is having the mass number 1 and charge number will be written as H1. 1 protons and 1 electrons will be there, no neutron. And the percentage of naturally occurring this protium is 99.98%. Next is deuterium. This is another isotope of the hydrogen, which is also known as hydrogen 2. It is known as deuterium. It has 1 electron and 1 protons, and also it has 1 neutron. It has 1 electron, 1 protons and 1 neutron, and having mass number 2 and charge is 1. Hence the symbol will be written as H12. Okay, because it consists of 1 protons and 1 neutron and 1 electron. Okay, it is generally represented as D also for deuterium, and the percentage of natural hydrogen is around 0.0156%, and plutonium and deuterium will be present in 1:15,000 ratio. So the heavy water, you would have heard that it is also known as deuterium oxide, which consists of deuterium isotope of hydrogen, deuterium oxide, which is also known as what? Heavy water, which is a isotope of what? Hydrogen. Okay. The heavy water will be used for moderator and the nuclear reactor to slow down the neutrons. So this is how we can see that the isotopes of hydrogen can also be used in different forms in their uses. Okay, deuterium will be mainly used in the form of deuterium oxide, which is also known as heavy water. The last isotope is tritium. This is a third isotope of the hydrogen, or you can say it is hydrogen 3. Okay, it has 1 electron, 1 proton but 2 neutron, and hence the mass number will be 3 and charge number will be 1. Hence it is written as H13 because proton plus neutron is a mass number. So it is 3 and the percentage will be 4 into 10 to the power of minus 50. Okay. So the properties of tritium, if you look into it, so it is usually radioactive in nature and it exhibits beta radiations or beta rays, and it has a half-life of 12.33 years and it is present in very trace quantity. This is how we can easily understand the isotopes of hydrogen, that is protium, protium, deuterium and tritium. Next is the physical properties of the isotope of the hydrogen. So first one is protium. Atomic mass will be 1.008 AMU and their abundance will be 99.988%. No neutron will be there and it is most stable form of hydrogen isotope. Next is deuterium. Atomic mass will be 2.014 AMU and abundance will be 0.012 and it has 1 neutron, hence the mass is almost double and heavier isotope of the hydrogen and is also quite stable. Next is tritium. It is having the atomic mass will be 3.016 AMU and their abundance will be 10 to the power of minus 15 and it is most stable isotope of hydrogen, has a half-life of 12.33 years and it shows a beta decay because it is a radioactive element. So these are the physical properties of isotopes of the hydrogen. Next we'll go for the preparation of hydrogen. In that we'll go for the first one, that is laboratory method of preparation of dihydrogen. That is the first method. Hydrogen is prepared in the laboratory in a small scale by the reaction of heavy reactive metals like zinc with HCl gas. So here the HCl gas is dilute in nature. Zinc react with hydrochloric acid forming what? Zinc chloride with the liberation of hydrogen gas. So this is a first way to prepare the hydrogen in very small quantity at the laboratory. We have one more method where hydrogen can be prepared by the reaction of zinc with aqueous sodium hydroxide. So zinc react with the sodium hydroxide, which is the base, forming what? Sodium zincate with the liberation of hydrogen gas. So this is the second method where by using the highly reactive metal known as zinc, by using an acid and bases, we can easily prepare the hydrogen in a small quantity. We can also prepare this hydrogen commercially. So how to prepare it? So the commercially hydrogen gas is obtained by electrolysis of acidified water by using platinum electrode. So here we will take a large container and we will use a 2 platinum electrode, and also we are using the acidified water. When you apply the electrical field, what will happen? The water will undergo electrolysis and give rise to the H+, that is the hydrogen gas, and also it liberate the oxygen. So this is how by doing electrolysis of acidified water also we can easily generate the dihydrogen gas. The high purity of hydrogen gas is around 99.95% is obtained by electrolyzing the warm aqueous barium hydroxide solution between the nickel electrode. So we can easily prepare the hydrogen gas by using barium hydroxide and also by using nickel as a electrode by electrolysis process. During this process, we can obtain 99.98% of pure form of hydrogen. So these two are the two commercial way to prepare the dihydrogen. We have one more method, that is dihydrogen gas is obtained by the product during the manufacturing of sodium hydroxide and chlorine by electrolysis of brine solution. We know that brine solution, which is nothing but a concentrated solution of sodium chloride. Is it right? So it is a saturated aqueous solution of sodium chloride, which is also known as what? Brine solution. So while preparing this sodium hydroxide also, we can itself generate the hydrogen gas. How to do with this? Let's say with the electrolysis cell reaction at anode, So what you are taking? You are taking the large container. To this, you are added the brine solution and you have introduced the two different electrode. One may be graphite anode, okay. Another one will be the electrodes of which you choose. I'll go with the nickel or with the platinum electrode, okay. When you apply the electrical field, we know that at anode, the chlorine gas will liberated by losing 2 electrons. These 2 electrons, will be later accepted by the sodium to form a sodium hydroxide. So at the same time, at the cathode, the brine solution will consist of water molecule. So it will react with carbon as the compound, which is a electrode, and it liberate what? Hydrogen gas with the formation of OH minus ion. Okay. Later, this OH minus ion combines with the sodium metal and forming 2 sodium hydroxide. forming what? Sodium hydroxide. That is why at the beginning I have told that this is a preparation step of sodium hydroxide. During this step, you are generating the hydrogen gas. In turn, you are generating the chlorine gas. So, overall reaction will be like this. Sodium and 2Cl minus and 2 water molecule give rise to Cl2, H2, 2Na plus 2 OH ions. So, which gives rise to what? 2 NaOH. This is how during the preparation of sodium hydroxide, we can generate the pure hydrogen and pure chlorine gas. Next is production of hydrogen gas from the coke and by hydrocarbon. By using coke and hydrocarbon, how do we prepare the hydrogen gas? Let's see now. Dihydrogen is obtained by the reaction of steam with the hydrocarbon or the coke at very high temperature. Here I have considered the hydrocarbon, which is allowed to react with water molecule. So, in presence of nickel as a catalyst at very high temperature, it gives us to what? Carbon monoxide with the formation of hydrogen gas. So, for example, I can take the hydrocarbon as methane, which is allowed to react with the water molecule in presence of nickel as a catalyst at very high temperature, it gives us to the carbon monoxide with the formation of hydrogen gas. This is how we can easily create the hydrogen gas, or we can easily develop the hydrogen gas by using hydrocarbon. Okay. The mixture of carbon monoxide and hydrogen gas, which is also known as what? Water gas. The mixture of carbon monoxide and hydrogen gas, which is known as what? Water gas. The mixture of carbon monoxide and hydrogen gas will be used for synthesis of the methanol and the number of hydrocarbon. So, this mixture, which is also known as synthesis gas or the syngas. So, when you react the hydrocarbon with the water molecule in presence of nickel as a catalyst at very high temperature, we know that it forms a carbon monoxide and hydrogen gas. The mixture of carbon monoxide and hydrogen gas, which is known as water gas. Remember, this gas will be used for preparation of many compounds. Hence, it is known as syngas or synthesis gas. Okay. Nowadays, the syngas is produced by sewage wastages and from the sawdust and scrap wood, and also by using newspaper. This process of producing the syngas from the coal, which is also known as what? Coal gasification or coal gasification will be called it as. Okay. Next, we'll see with the reaction of coke with the water molecule to liberate hydrogen gas. So, the production of dihydrogen can be increased by reacting the carbon monoxide of the syngas mixture with the steam in presence of iron chromate as a catalyst. This is known as water gas shift reaction. Remember, so once we obtain the mixture of carbon monoxide and hydrogen gas, we can increase the production of hydrogen gas by using the iron chromate as a catalyst by treating the carbon monoxide with the water alone. So, when you treat the carbon monoxide with the water alone, you can expect this formation of hydrogen gas as it is compared in the first step with the liberation of carbon dioxide. This process, which is also known as water gas shift reaction. The carbon dioxide is removed by scrubbing with sodium arsenic solution. Presently, 77% of industrial dihydrogen is produced from petrochemical and 80% from the coal and 4% from the electrolysis of aqueous solution and 1 from the other sources. So, this indicates that how we can easily prepare the dihydrogen by using coal as well as with the hydrocarbon. Remember, when it is react with the hydrocarbon, it forms a mixture of carbon monoxide and hydrogen gas. When it is react with the coke, it will form what? Again, carbon monoxide and hydrogen gas. In order to improve its production, We are treating the carbon monoxide with the water, so it will form a carbon dioxide with the liberation of excess quantity of dihydrogen. So hope you are understood with this preparation and the occurrence and the resemblance with the alkali metals as well as with the halogen, and hope you are understood with the position in the periodic table. In the next session, we are going to discuss with the physical properties of dihydrogen. By this, I like to say that which all the things which I covered in this session, it is very important for the examination point of view. Have a look on it. We'll meet you with the next session. Till that, take care, be safe. Thank you.